Hi, my name is Antonio Gonzalez Jr. I'm a graduate student of developmental psychology at the CUNY School of Professional Studies, and I'm currently taking Psychology 600. This is my research prospectus, and it is entitled, Does Impaired Vision in One Eye Impact Short-Term Memory? We'd like to know the answer. As part of the research problem in question, it is currently unknown to what degree vision impairment is misdiagnosed as mild cognitive decline and dementia. But the distinction is important. Regrettably, dementia carries a social stigma with quality of life ramifications. As a research question, this prospectus asks whether or not visual impairment in one eye significantly impacts cognitive processing, specifically short-term memory as a measure. As part of the research hypotheses, the null hypothesis states that the visual impairment of one eye does not significantly impact short-term memory cognitive processing. The alternative hypothesis, however, states that the visual impairment in one eye significantly impacts short-term memory cognitive processing. As part of the context and literature review, per the American Academy of Ophthalmology, over 24.4 million Americans and half of Americans over 75 suffer impaired vision to some extent. An article written by Matthew Solon, editor of the Harvard's Men's Health Watch, reported a significant correlation between older adults and dementia diagnosis. Science News, however, reported significant misdiagnosis of impaired vision as mild cognitive decline. J.J. Gibson, in 1979, proposed a bottom-up theory regarding cognitive processing. Here, external stimuli were received by sensory organs, the data processed, with the resulting and selected output passed to higher cognitive levels for further processing. Austin Clark in 2003, as cited by Sternberg and Sternberg, proposed a top-down processing theory where expectations and prior knowledge directed perception. Today, research leans towards a bottom-up, top-down processing model, as proposed by Cutting and Galowski in 1977 and Palmer in 1975. Visual input begins in the eye and is passed to the occipital lobe and visual cortex for further processing. This is per DeWeerd in 2003, as cited by Sternberg and Sternberg. This processed information is then passed further, such as to the thalamus, for general distribution. Again, as cited by Sternberg and Sternberg. Under proposed methodology and design, measuring the effect of decreased visual sensory input on memory testing is the purpose of this proposal. Specifically, short-term memory testing in subjects with impaired vision, here defined as 20/400 or worse, in one eye is compared against subjects with unimpaired vision in both eyes, here defined as 20/40 or better, as measured by a certified optometrist. To counter aging and general health confounding effects, a matched pair design using 40 pairs of randomly selected subjects from 20 to 80 years old will be employed. Subjects with impaired vision in one eye are placed in the test group and are matched against subjects with good vision in both eyes in the control group. Test and control subjects are matched based on their gender, their age, and general body mass index category, which would be underweight, healthy, overweight, or obese. All subjects are assigned a unique identifier and their impaired eye noted, such as right eye or left eye, as applicable. As part of the test procedure for round 1 testing, each subject signs into the online test application using their unique identifier. Randomly generated strings of mixed lowercase letters and numbers of 3 to 10 characters are presented on a monitor. Starting at a length of 3, the string length increases as the test progresses. After a 3-second pause, subjects have 15 seconds to enter their response from memory of what they just saw on the screen. Subjects repeat this for 3 different presentations before the string length increases to the next level. After completing round 1 testing, each matched pair will repeat the entire process wearing a translucent patch placed over the designated impaired eye for both paired subjects. Scoring is done by measuring the correct number of characters entered in sequence per string. Statistically, an ANOVA analysis will be done between groups and within groups. That would be control versus test groups, control versus control group, test versus test group across round 1 and round 2. In conclusion, in round 1 testing, a significant difference is expected to be found between the impaired test group and the unimpaired control group. In round 2 testing, however, it is expected that the impaired test group will not significantly differ from the impaired control test scores. So why is this distinction important? It is important because it shows that the general difference in short-term memory ability between groups is attributable to a visual impairment and a lack of available sensory input data, not because of a decline in cognitive ability. These expectations are found true. Legislative steps should be taken to ensure that those with visual impairments are provided with larger fonts on printed material to include labeling, contracts, and larger signage. If dementia is suspected, additional cognitive and visual testing should be done to ensure accurate diagnosis of the condition. Misdiagnosis can result in social and quality of life consequences that really matter. Thank you.